Hello, in this video, I'll be going through the Set 3 Term 4 test for 2021. When we set this paper, we actually wanted to give you a preview of the difficulty level of your upcoming end of year exam. So when you look at this paper, you will see that most of the questions are adapted from the TYS, and that is a way for teachers to encourage you to actually use your 10-year series as a practice. So if you really want to do well in your physics, it is very important that you make use of the TYS and use it to find out the areas that you are not very sure before the exam. And because the 10-year series is basically questions written and designed by Cambridge, it also serves as like a sample for you to familiarize with how Cambridge actually write their questions. So as I was saying, you will notice that as I'm going through in this video, I will be pointing out to you which are the questions that I have taken out, which I have adapted from the 10-year series question. And you should, if you didn't do very well in this paper, then you should be asking yourself, why didn't I make use of the TYS and actually look at, if I don't have time to do it, at least I can take a look at it, and then I can take a look at the answer key and see the approach. And you should be also asking yourself is, if you do not have the time to actually try out the question, then you may want to reflect on the way you prepare for the exam. So for my class, I have been telling them that when you want to prepare for an exam, you cannot prepare for it the day before. Similarly, when you go for a dental checkup, you cannot rely on that one time that you brush your teeth before the examination. You have to keep brushing your teeth every twice a day in order for you to have a presentable set of teeth when you go for your dental checkup, right? So it is very similar when you prepare for exam. So when you know the exam date, it is important for you to at least try maybe 2 questions a day, so that when you try it out, you realize that I really do not know what is this. I totally do not understand. So it is very normal for students not to understand the topic, but it is your responsibility to actually find out that now I realize I kind of forget or I don't get it. Then you need to go and seek help either through from your friend, or best is that you go and text your teacher and say that I really need help. Out of the 4 questions I try, 3 I do not know how to approach, so that you have enough time to actually prepare for exam. It is life. That is how you prepare for exam after set 2. You cannot use your primary 6 way of preparing for exam, like last minute you try your very best and then I can do well, but in upper set it is very challenging. So anyway, let's start with our video go through. Okay, so for your question 1, basically down here, after the marking, right, we actually had a benchmarking session whereby the physics teacher came together to decide what is considered as acceptable and what is not. So for this particular question, I have to apologize first, because I think here when I say in terms of decimal place, then after that I slash dp, right? By right, I thought I have make it very clear that I am expecting something like 1, 2, 3, that kind of answer, because if I write 1 here, it means 1 dp in cm, and because the question also make it very clear to you that I want to know the number of decimal place, so I'm expecting whole number. But in view of the sudden increase in terms of difficulty level, when I compare it between this paper and the previous paper, some of you are writing it in terms of like this or like this. Okay, for this round we will accept it. Okay, but if I want to be strict, right, technically if you look at this, I have already given you dp here. You don't even need to write dp over here. So I would expect my answer over here on the dotted line to be just whole number. Okay, for the purpose of this video, I'm not going to tell you the exact answer because all of this you can find out from your lab 1.1 the precision table for each equipment. Just to let you know, for this particular case, the different measuring cylinder, right, you can't just memorize precision for a measuring cylinder. What you need to know is that you need to read till half the smallest interval. Okay, this is special for measuring cylinder. The precision is given by half the smallest. So what you need to do is, for example, if this is 50, then the next smallest interval here will be 51. So half the smallest interval, meaning that you can read till 0.5 ml. So in this case, you should give me 1 dp. Okay, then of course, due to the format that I have given you, you don't even need to write dp here because dp is already given in the heading. Can? I just want to caution you, this half the smallest interval, right, it does not apply to all equipment. So I just want to highlight, this is not a general rule. Okay, it only applies to some instrument. Okay, for example, one of them is measuring cylinder. So go and read up on the precision table and memorize which are the equipment that you need to read to half the smallest and which one is just the smallest interval. Okay, moving on. Question 2 basically tests you on your ability to apply your precision rule. Again, down here, right, the method and the logic behind it is given in your lab 1.1 worksheet or 1.0. But anyway, I will be just running through the logic very quickly. So for example, if you want to find write down the reading on R, here you can see that R is given by the formula V divided by 1. So if I want to find the answer here, what I need to do is that I need to sub in. And when I sub in the thing, you will notice that V is 3SF and I is 2SF. And when we do a process or an operation like that, we say that this is basically a reading divided by another reading. So for such operation, we follow the least SF. So in this case, the least SF between the two is 2. So therefore, you will keep your answer here to 2SF. Similarly, over here, when you do the other row, here I purposely put a 1SF reading here. So yes, if you apply the rule, if you apply the least SF rule, the least SF is indeed 1SF. But I have also highlighted, or many teachers have highlighted, that in physics, we don't do 1SF. If you see 1SF, please automatically up it to 2. So as a result, down here, it will also be 2SF. Okay. So once you understand this logic, then V square is quite similar. V square simply means that you take the voltage and you square it. So in this case, you will also apply the least SF rule. Okay. So if you apply the least SF rule, you will see that for the top row, it will be 3SF, and for the bottom row, it will be 2SF. Okay, for your part B, basically I'm trying to test you on your ability to read the coordinate according to the precision. So let me talk about the coordinate first, okay? How do I know how many dp should I have when I write my coordinate? It is not by this. Some of you have the misconception and think that, oh, since the scale reading is in 1 dp, then my x coordinate should be in 1 dp. No, this is not true. What you need to do is that you need to take the interval here and divide it by 20. So this is how you should do it, just like your practical. You will find that the answer that you get, right, will be a value of 2 dp. So with that, you will know that your x coordinate has to be of 2 dp. If you do the same thing for your y-axis, you will notice that your y-axis will follow a precision of 2 dp as well. So that is how you figure out how many dp your coordinate should contain. Now when you are asked to find a gradient, you should pick 2 points that is on the line. So you shouldn't be using these green color crosses, which is from the experimental data, because they contain random error. So this one, you may want to put down the notes. Do not pick experimental data directly to compute gradient. Okay, because they contain random error. So what you should do is that you should pick 2 points on the line, and these 2 points should be at a position that is very easy to read. For example, you can see that the point I pick here is very easy to read. I don't even need to do any division. I know that it is 4.55, 4.65. Similarly over here as well. And you should pick the point such that it is far away from one another. You should try and pick one that is as far as possible while being easy to read. So what are the rules that you need to take note of when picking points for coordinate? You should pick points that is far apart, and you should pick points that are easy to read. So once you have do that, your gradient working will be as follow. You will apply the least SF rule. And if you apply your least SF rule, you will see that the least SF is 3SF. So hence, you will see that your gradient will follow 3SF. And how do you find the unit? It will be the y-axis unit divided by the x-axis unit. So here you will see that this unit here is basically make up of y-axis unit over x-axis unit. Now for part 2, we have been trying to teach you this for a long time over many practicals. So how you do this is that you need to compare coefficient. So here you are given a formula that you were not taught. Your objective is to arrange this such that it looks like this. Now what is this? I want this to be my y-axis label, and this is my x-axis label. These are constant. So in this particular graph, my y-axis is r, right? This is my y, and my x is v squared. So in a way, my job is to turn this into something like this. Okay, can? So this is my objective. Right, I want to turn the given formula into this. Okay, so that is my objective. So here, that is what I'm trying to do. So I write down the equation, P equals to V squared over R. Because I know that I want to make it into this form, I need R to be on one side. So that's why I move the R from the denominator position to here. So since I know that on the left hand side, eventually I want R to be there only. So what I do, I shifted the P to here, right? So when I shifted the P to here, I realized that this is the final equation that I have. So now if you compare between these two, if I were to write them, write the two equations above one another, this is how it will look like. So what I notice is that this part here, the M, right, represent my gradient position. So hence I know that the gradient of my R versus V square graph will be equals to 1 over power, whereby power is a constant. Okay, how do I know that power is a constant? Well, because that is what I want to do, right? How will the voltage across above affect its power, right? So power is my constant. Okay, for your question 3, it is on sound, and I have to say I'm quite disappointed that many of you forgotten how to do it. Now if I bring you back to a few weeks ago, if you refer to your worksheet 15.1, you will actually see a very similar question, which is your question 4. So in question 4, you were given some lines. This line represents air layer in its undisturbed position. After that, you were given, at some instances, the new position of this air layer. And you are asked to determine where is the compression, where is the refraction, where is the wavelength, and the amplitude you're supposed to measure. So actually this is from your homework 15.1. You can go and refer to it. You will see that the question is very similar to your test. So here, what you have is that the top row, the top row actually represent arrangement of air molecule before the sound wave passes through, meaning that these things are like the original position of the air molecules. At a certain time, when the sound wave passes through, this is what you see. So these are the disturbed position. And just by looking at it, you will see quite clearly that there is this particular molecule that were not disturbed at all. Can you see? And of course, this guy as well. So in sound, the behavior of compression and refraction is that the center of the compression will actually show you zero displacement. So when the molecules are at its original position, we say that the displacement is zero, because displacement refers to the new position versus the old position. So if the new and old position is the same, we say that displacement will be zero. So similarly, this will give me the center of refraction, and this will give me the center of compression. Okay. Another thing that you will notice is that there are some particles that are moved by a larger extent. So if you look at part A, they ask you to measure amplitude. Amplitude simply means you want the maximum displacement. And this you can find by trial and error, right? So if you look at this pair, the blue pair to this versus this pink pair, okay, maybe the color doesn't appear that sharp. Let me redo it. Blue pair and the pink pair. You can see that they are being moved by this distance. This is their displacement. So just by doing these simple sketches, you can actually see that the light blue pair is showing you the maximum displacement. So by counting the grid and by looking at the scale over here, you can actually determine the amplitude. So this, you go and work it out. For measurement, right, if you are measuring something, if you are using ruler or the grid to measure, you do not need to round up to 2SF. Just leave it as what you have measured. Okay. Okay, part B is actually also a homework question, but it is in your wave worksheet. So for wave, what you have learned is what? If now I show you this is the wave at a certain instant, let's say this is time equals to 0. And I tell you that I want you to sketch, okay, the wave after half a period has passed. How would you sketch this wave diagram? Well, first, maybe I will give you some guidelines like this. Well, after half a wave passes through, what will happen is that the crest over here, this crest, the red one that I have drawn, maybe I use a highlighter, this crest would have moved to here, right? Because half a period meaning that half a wave is generated, and therefore this green color crest would have been pushed to the next position. So therefore, this is what will happen. Right, the crest would have been pushed to the right by half a wave. Correct? So similarly, if you have a longitudinal wave whereby this is your center of refraction, this is the center of compression, and this is your center of compression, when half a period has passed, what will happen is that this center of compression, would have moved to here, the green highlighted place. And the center of refraction, the green one, would have moved to this light blue position. So therefore, what happened is that the compression over here, the yellow one, would have moved to here. So let's call this C1, would have moved to here. And R1 would have moved to here. So what is this? Well, this will be your R0, the one that was newly made. And then your C1, I shouldn't call it C1, but I can call it C2 lah, but let's not make it confusing, would have appeared here. Right, notice that I say compression and refraction has moved. Did this air molecule, and this air molecule move? No. Okay, so please remember that it is the center of compression and refraction that has moved. The molecule only vibrate. Remember, wave does not transfer matter, right? So it is the center of refraction that has moved forward, but the molecule itself, this red color one, didn't move along with it. It just vibrate left and right. Okay, if you are not sure what I'm talking about, please ask your teacher. I guarantee you this concept will be tested again in end of year exam. Okay, so if the particle didn't get carried along, well, these dots will reappear here, but because this is now the center of refraction, it will be these light blue color particles will be distributed differently. So down here, what you need to notice is that, okay, from compression to the next particle, this guy to this guy, it actually occupied 1, 2, 3, 4, 5 square. So do the same thing over here. 1, 2, 3, 4, 5 square. So this will be your neighboring molecule. 1, 2, 3, 4, 5 square. This will be your neighbor. Then after that, from the refraction, I would have I would have one big one plus 1, 2, 3, 4, 5. So one big one, 1, 2, 3, 4, 5. One big one, 1, 2, 3, 4, 5. Okay, then down here, one big one, 1, 2, 3, 4, 5. Okay, and finally there will be one more here. Then after that it will be 1, 2, 3, 4, 5. Okay, so that is how you should sketch your dot diagram. And just to give you some hints, if we know that in the term test these are your weaker question, there is a high chance that in end of year we will test you similar concept to see whether or not you have learned from your mistakes. Okay, for your question 4, for those of you who have a TYS, you can look it up. This is your 2015 paper 2 section B question 11A. It is in your TYS, so please take a look at it. Okay, now when you are given such question with so much data, this is like a preview to you. This is what we call a database question, whereby the content is mixed with data that is given to you in different representation, some in graph, some in words. So when this happens, I always advise my student, whenever they see something like that, they should take note there is a prefix. So 10 millisecond, basically it is 10 times 10 to the power of minus 3 seconds. For pure physics syllabus, we will always test you on prefix like this. So it is always good that when you are given a scale, you always circle it and then highlight with a star, that is me, and then write down that there's a prefix for you to take note of. Okay, most of you have no issue with part A. You can see that the P graph has a larger amplitude than your Q wave. So many of you are telling me that Q is soft, whereas P is loud. But the problem with many of you is the pitch. You didn't take note of the number of square. So down here, you can see that the wave is not in sync. So what is mean by in sync? You can see that the crests are not matching. So the crest is here, but then the crest got moved. So how do you determine the pitch? Is by the time taken for a complete wave, or you can also use frequency. So this is one complete wave, the one that I draw in purple. You can see that for one complete wave to form, it takes 2 square. Now if you look at wave Q, for one complete wave, I start from the bottom. This is also one complete wave. You can see that it also takes 2 square. So actually your wave P and wave Q has the same period or same frequency. So therefore they have the same pitch. Okay, for part B, you are given 2 answer line and the marks are 2 marks. So I would expect you to give a little bit more detail. So what happened is that it is actually quite straightforward. We just want to test whether you can express your thoughts clearly. So what the question is trying to say here, that if you look here, peak P and peak Q are caused by the same wavefront, meaning that when the speaker first start to vibrate a layer of air, this layer of vibration, okay, maybe it's a center of compression, is going to travel forward and it will hit microphone A first. So this compression that hit microphone A will give you P. This peak is registered because of this. So after this wave hit microphone A, it is going to continue its motion and travel forward. And when it hit microphone microphone B, it register this peak over here called Q. So technically P and Q are made by the same wave front that is from the speaker. So here you will notice that you can actually find the time taken for this wavefront to travel all the way to B, because you can read this part over here. Okay, so anyway, to answer part B, it is quite straightforward as long as you can express yourself in clear, concise sentences. Why is peak Q on the right side of P? So number one is that you need to highlight to me that, oh, if something appear to the right side, it means that this event has happened at a later time, excuse me. Okay, so as a result, you have to tell me that, oh, okay, your microphone A is nearer to the speaker. So as a result, your sound wave will reach A first. Okay, in another word, you are trying to tell me that yes, you can interpret this graph and you realize that, oh, okay, by having the peak on the right, it means that that particular wavefront is actually arriving at a later time. So you need to show this concept very clearly to me so that I can avoid you this mark. Now, in order to calculate, okay, I'm moving on to part C. In order to calculate the speed, many of you are using V equals to F lambda. Very quickly, you all will jump to a conclusion, I have to use V equals to F lambda. But for database question, you need to think. Okay, it is not necessary that you use V equals to F lambda. In fact, if you use V equals to F lambda, you will find that you do not know what is lambda. Yes, you can find frequency from the graph, but you realize that you cannot find lambda and you will be stuck. So the way to do it is to interpret it. You will see here that P and Q, you can find the time taken for the wavefront to reach from P to Q. So because of that, down here, you can see that it takes 1, 2.5 division. So 2.5 division corresponds to 25 millisecond. And because you know the speed, you can use this formula because speed is constant. So with that, you actually can find the distance between the two speakers and remember to round it off to 2SF. Okay, for your question 5, it is also a TYS question, which is actually your 2011 paper 2A Q5. Okay, basically as long as you show me that you know it has to be sandwiched and that the emitter and detector is on either side and it should be near to your sample, you will get the full 1 mark. Okay, for your question 6, right, it is actually in your kinematic worksheet. It is the total versus rabbit question. Okay, it's just that now I changed the total to a sports car and the rabbit is the sports car and the total is the train. Okay, so not much of an issue for part A. You all are following my instruction, adjective plus noun format. Okay, your adjective, there are only like a few: increasing, decreasing, constant, or even 0. And of course, your noun is either VA or whatsoever. Okay, so many of you can get the answer, so I'm not going to touch on it. Okay, to calculate the time, right, there are many ways to calculate. Some of you like to do it in by comparing the area. I will give you the full mark if there is very clear statement of what you are doing. But many of you gave me some weird presentation, which I cannot give you the full mark. In fact, some I give 0. Okay, so how to properly tackle this question? You can actually refer to your rabbit versus total question in your homework on kinematics. It is the same. So first of all, you need to tell me that in mathematics, when the sports car catches up with the train. Essentially, it is when the distance are equal. And for the train, because it is a constant speed, you can just take it as 8.5 times t, whereby the t is the time when the sports car catches up with the train. As for the sports car, it is a little bit more complicated because the speed is increasing. So to find the distance covered by the sports car, you need to find the area under the graph, which is given by half times base, which is t, multiplied by the height, which is v. So that is how I get my expression here. Now, once you reach this step, you will find that you have two unknown. You have v and you have t. Okay, so what you need to rely on is that actually you know the acceleration of the sports car, because you can read this point, which is 0.3, 8.5. So once you know that, you can actually find the acceleration of the car. And once you find the acceleration of the car, you should know that a is equals to v minus u over t. Okay, so this is from this. So the final speed of the car is an unknown. You do not know what is that. But you know that the car starts from 0 and it takes time t to reach the velocity. So from here, you can actually get this expression whereby v is equals to at. So you can substitute it here. And if you do some manipulation, because now this guy over here, acceleration of car, you have already found it over here. A is equals to 28.3. So by doing some mathematics, you can actually work it out and you can solve that t is actually 0.6. So once you have t equals to 0.6, you can then move on and solve part C. Now, it is actually quite disappointing because some of you leave your part B blank, and as a result, your C is also blank. So one of the exam tricks is that if you see this word hence, you should quickly refer to B, and if touch wood, your B is, if let's say unfortunately if your B is blank, what you should do is that for part B answer, right, just put some dummy number here. It can be 4, 15, 12, 20, up to you. Just put a dummy number there so that you can make use of your answer in B, and then you can sub it into C and you can at least get error carry forward. Okay, so I'm not going to talk about C because it is very straightforward once you find the time. Okay, for your part D, this is your distance time graph. Okay, for your distance time graph, you should know that both of them start from 0. So distance time graph, you need to know this piece of information, and that is the gradient is actually representing velocity for dt graph. Okay, please do not get confused. Your gradient of vt graph will give you acceleration. So there's a difference here. So down here is actually quite straightforward. You know from your part A that your velocity is rising, as you can see from the green line. So if you bring this over here, car velocity is increasing. So what does it mean? The gradient of that line will be increasing. So when you have the gradient rising, this is the kind of line that you will get for car. Now, if you look at the train, when the train velocity is constant, that means what? That means the gradient of a dt graph will also give you a constant gradient. So therefore, this is the line that you will be getting. So that's how you get this graph. Now, to get this graph, it is very important for physics pure syllabus especially that you always label all your point of interest. So therefore, you have worked out that they will meet each other at 0.6 seconds, and then the distance that they meet each other will be 5.1. So that's how you get this. Yeah. Okay, your question 7. Okay, for your question 7, it is actually a pretty challenging question. But again, this is from your TYS 2020 paper. So it is rather new. So how you do, quite straightforward. Number 1, you notice that this is your velocity graph. So the ball is released from rest. So therefore, you should have so I will always draw a table to remind myself. So release from rest, right? Time equals to 0, v equals 0. Then I'll put a cross here. So we undergo free fall. What does it mean? Undergo free fall meaning that your acceleration will be 10 downwards. Okay. It will fall towards the ground 6 seconds later. So what I will do is, this is my point A, v is 0, this is the ball. It will reach the ground, so this is before impact. So I will write here, this is my B, this is my A. Before impact, right, 6 seconds. So time equals to 6 seconds, meaning that my V will be how much? If I know that my speed is increasing by 10 meter per second every second, so this means 60 meter per second, right? So I know that here time is 6, this is 60 meter per second, right? Then after that, the ball hits the ground. Okay, the ball hits the ground. So I will draw all the factors out first. So this one is 60. The ball hits the ground. So this one is after impact. So ball hits the ground, the velocity should be up. Okay, then it rebound upward. No, that's why I rebound upward. So there's a C. Okay, that's a C. So it still happened at 6 seconds. So this one is downward, I should have upward. Okay, but I do not know what is this speed. But I know that it reaches a maximum height of, I know that it reaches maximum height at t equals to 10. So meaning that it will reach a maximum height. This is max height, t equals to 10. And at max height, my velocity will be 0 also, right? So I will say this is my D, 10, 0. So what I have is maybe 6 seconds. So 2, 4, 6 seconds. Wait. There is a, which positive is up or down? Let's take a look. Downward as the positive direction. So downward as positive direction, meaning that this will be positive, this will be negative. Okay, so positive 60. So 2, 4, 6. Okay, I put here 60. So that's one more cross. This is my B, this is my A. Then C, I have no idea what is the velocity, so I'm not going to worry about it. But I know time is 10, 2, 4, 6, 8, 10. And this will be my D. Right, so if I'm stuck here, so be it. But I will know that from here to here will be a straight line because it is free fall, right? It's free fall. So if I know that this is my acceleration, when my ball is bouncing up, my acceleration should be the same because I'm in the same gravitational field, right? So therefore actually here I will still have the same acceleration. This means that if this gradient will give me 10, this means that I should have the same gradient over here. Right, so this gradient should still be 10. And if you draw it carefully, you should be able to get your rebound speed, which is negative something something. So I leave you to actually find this out, because on the iPad I do not have a ruler and I cannot draw this to scale, because for the question it asks you to draw the graph and use the graph to determine this particular velocity. So you need to find this. Okay, for question 8, it is I think most of you did pretty well. It is a standard dynamic question. I just want to caution you, because it is a new topic, I actually set this question to a lower difficulty level. You will notice that there is very little context, and basically I'm just testing whether you can apply your Newton's second law and your third law correctly in this case. So in end of year exam, we will give you more challenging question on dynamics. So if you find that you are still having difficulty to actually interpret this question, please seek help from your teachers. Okay, there's no point of going to an examination knowing that you have some weakness that you have not addressed. It is like going for it is like you going to act in a play, and then you know that you have not memorized the script, but yet you still go on stage. Okay, you are going to have a very bad experience. So the minimum that you have to do is that you need to make sure that you know your script. And by script in physics, it means that you know how to apply your formulas. That is the minimum, okay, in order to pass. Okay, for question 8, number 1, you need to be very mindful that I want the full names. So as a result, if you didn't give me the full name, you will not get the full mark. For normal contact force, you have to give me that 90-degree symbol. And for friction, please make sure that you draw your friction on the surface that the friction is acting on. Okay, for the weight, now that in a moment you already know about this thing called center of gravity, the next time you have to sketch your weight, it has to be on the CG. Okay, it has to act on the CG. So this is very important. Okay, then after that, for your part B, it is basically your Newton's second law. I have made some, I've skipped some step. Technically, what has happened before this is that you should start with your Newton's second law, and then you turn your Newton's second law on the left hand side, turn it into the definition, sum of forces, and if you do that, you will be able to get this expression at the top. So for your sum of forces, please take note that you need to be mindful about the direction. And you will also notice that for the sum of forces, I didn't consider N and W, because your N and W are vertical forces. So actually down here, I am only considering the horizontal forces. Okay, so in this case, the horizontal forces, there are two of them, P, maybe I don't use pink, I use green, P and F. So since P and F are in different direction, they shouldn't have the same sign. It's either F minus P or P minus F. But since you know that the acceleration is going to be towards the right, okay, where is it? Okay, so it is moving, right? So towards the right. So as a result, your A and P should be of the same sign. Okay, so if you do the signing and you write the expression correctly, and here you can also see that we are being very kind to you. We have actually changed the mass into kg already. In end of year, I think chances is we will set the question such that the mass is in gram, and if you forget to convert, then you'll be in some kind of trouble. You will not be able to arrive at the correct answer. Okay, so that's how you solve the question. Like I said, this is the basic. If you are having difficulty here, do seek assistance from your teacher before the exam. Okay, for your part C, I'm actually testing you on your Newton first law. Sorry, not third law. I think I say third law at the beginning of the video. So in this case, we are testing you on Newton first law. So what is Newton first law? So here in the question, they are saying that before anything that has happened, oops, I spelled before wrong. Before anything that has happened, what we have gotten is that the friction is 1.4 and that the P, the forward force, is larger. So therefore, it resulted in acceleration, right? Then this means that before it is already moving, right? So now what has happened is that the forward force has been reduced to 1.4. So now you can see that the friction and the forward force is actually of the same magnitude. So there are two approaches to answer this question. Number one approach is by just pure understanding that an object that is already moving, if there is zero net force, according to Newton's first law, then it will continue moving at same velocity. This one is covered in Newton's first law. Okay. If you do not want to use laws, you are more mathematical inclined, then you can also look at this using your formulas, which is your sum of forces equals to MA, right? So now your sum of forces will be 1.4 minus 1.4. You will get 0. Since mass cannot be 0, it means that your acceleration must be 0. So when acceleration equals to 0, meaning what? Meaning will it stop moving? No, right? Because it is already moving. In order for something to stop moving, you are changing velocity from having something to 0, right? So it means what? It means that there is some acceleration. But in this case, if acceleration is equals to 0, what it means is that your velocity has no change. It will still be the same value. So therefore, when your P is being reduced to the frictional value, actually the object will just continue moving at the same velocity. Or you can say that there will simply be no acceleration. Okay, so for this, describe the subsequent motion. There are many ways to do it. You can either say that your velocity will be constant and you will continue to move, or you can say that it will continue to move, but now your acceleration will be 0. So either way will give you the marks. Okay, so that will be the end of the